Thanks so much, Robin. Just to clarify before I start, it's Saga. No problem at all. No problem at all. The only reason I'm saying that is I don't want the lawyers at Saga to come after us. So it's Saga. And I'm thrilled to be here with you guys. So we have a very important talk happening today. In terms of timing, it could not be more perfect. So for those of you who are in this room, good job, because you're about to get alpha that is actually going to have some sort of financial implication. So for all those losers out there who are enjoying their box lunches, have fun staying poor. So let's get into it. So for those of you who may not be familiar with Saga, Saga is a layer one, but we are a layer one to launch layer ones. And the reason we architected ourselves that way is we are looking for infinite horizontal scalability. So infinite horizontal scalability. So what does that actually mean? Let's talk through first. I have to walk this way. There you go. All right. We needed some choreography for this, but that's okay. So why horizontally scale? Well, let's talk about what is horizontal scalability versus, say, vertical scalability. So vertical scalability is what, say, Solana is trying to do. So Solana is very much a one-chain maxi. For those of you doing SVM rollups out there, you probably know that intimately. But what they try to do to scale is they try to stuff more compute into one chain. And that works up to a certain point, but then that gets congested too. And then once you get more user traffic in there, filling up the chain, then that inevitably goes down. Horizontal scalability means that you never run out of block space. So you have your one chain, but then your exercise of scaling involves adding block space. So in our case, it is adding chains. So Saga is a layer one to launch layer ones. Every developer who builds on here is by definition on their own chain or set of chains, which we call chainlets. All of these chainlets are fully decentralized proof-of-stake chains. They are layer ones in their own right with their own native token, and therefore they have all the functionality of a proper layer one. We automate the instantiation of these chains. That is the gift that we have given to developers, and they can have as many as they like, supporting the performance of their application. So why horizontally scale? Why architect it this way? So vertical scaling has the inherent limitations that I just talked about. It's a limited capacity, unpredictable costs. We all hate gas, but expensive gas is one thing. Expensive and unpredictable gas is really very, very hard for developers, even harder for end users. There are single points of failure. Again, chain goes down, there's nothing you can do about it. And then inevitably what happens is once the chain launches, and it is a monolithic chain, then the pace of innovation is going to slow down significantly because you aren't having your community and the entire ecosystem add block space to that particular chain. It is really dependent on the core team to upgrade that chain in order for any new innovation to happen in that space. Okay. So horizontal scaling infrastructure does not have any of those problems, so it is better. However, there are other issues with it. So again, walking this way, this is a pro tip for speakers who are coming after me. You gotta point it at that computer on the right-hand side, maybe. Yeah, I'll just shout it out to you if that's okay. Thank you. Okay, so horizontally scaling L2s versus L1s. So we all have had rollups and roll-up protocols stand up over the course of the last few months. We've had a lot of L2 stood up as well. And I think for many people, genuinely, this was the way that they thought scaling should happen. It was also a nice way to get some sort of token value extraction. However, there are some significant technical considerations here that I think every developer should take into account when they decide where to build. So is it horizontally scalable, first and foremost? So horizontal scalability, once again, means that you're adding block space to the existing block space. So that can happen for rollups, L2s, as well as app chains and L1s. Is there fast finality? So for rollups and L2s, no. The answer is there is no fast finality of your transaction. So settlement times are incredibly long. In some cases, it can take up to a week, if not longer. So for some people, that's totally fine because you want the privilege of being on that rollup or that particular L2. But obviously for higher volume or higher traffic applications, this is not tenable. Whereas with app chains and L1s, you do get that fast finality. Is it fully interoperable? No, this is one of the big problems of rollups and L2s. This is why we talk so much about liquidity fragmentation. It is because when you have a rollup and L2 architecture, everything is fragmented. This is the big problem that is plaguing Ethereum. And it is the problem that Ethereum 2025 is trying to solve. With app chains and L1s, everything is interoperable. Now, why is that? It is because in order to actually have interoperability, you need to have bridges, right, that move in between the block space. Now, these bridges are not going to transfer assets unless that they know the sending chain and the destination chain are secure. Now, when you have a fully decentralized proof-of-stake chain, like an L1, they know that their security, and therefore they can trust the transaction that's being sent. The bridge will open up immediately and you can go ahead and settle your transaction. Whereas on a rollup or an L2, the security architecture is obviously much more complicated and therefore you have to wait. So interoperability doesn't really exist in a rollup and an L2 environment, hence fragmentation. It is fully self-contained. I don't think I need to explain that too much more. With the rollup and L2, you do need significant additional tooling as well as infrastructure partners in order to actually have a full chain experience, whereas with an L1, it's self-contained. Predictable low costs, this is a big one. So right now, it is true that the cost for being on Base, for instance, or any other ETH rollup or L2 is a lot cheaper than being on Ethereum. Having said that, cheaper is still not competitive with zero. So with an app chain and layer one, you are able to get gas costs down to zero. You can also hide gas costs entirely, which is what we've done at Saga. So it is a completely gasless experience to be on chain here. And it's only possible because it is an L1. Decentralized and secure, we already talked about that. Easy to deploy. So it used to be that with rollups and L2s, you could do it at a click of a button. Maybe more so for a rollup. For an L2, you still need a little more construction there. But for a layer one, you needed to gather your validator set. You needed to have a security model. You needed to have your own native token. It's incredibly expensive. And I think for a lot of application developers out there, they felt that this was way overkill for what they wanted to accomplish. And so it was difficult to deploy that L1. So, can we go to the next one, please? Thank you. So what we decided to build is a layer one to launch layer ones. If you look up the Saga app on our website, freely available there, you can launch your own layer one in about 2 minutes. It takes 5 seconds to fill out the chain parameters, and then you gotta wait for the validators to sync. But every single layer one that is launched on Saga is a replica of our mainnet. Okay, so we have automated the launching of layer ones. Now, if you need an additional layer one, it's the same process, and you can have those layer ones talk to one another. So you can scale out elastically to as many layer ones as you need in order to support the performance of your application. So it is a better experience at the end of the day for any developer out there, certainly. But I think for users, particularly those who are on high traffic applications like a DEX or like a game, this is just a much better system for them to experience that application on. All right, let's go to the next one. Thank you. So why horizontally scale? We've already talked through a lot of the reasons, but some of the things that I want to emphasize as we move forward in this presentation, because it'll be relevant later, is token economics and costless transactions. So in addition to performance of the system, security of the system, we want to talk about the actual cost of it. So already I've said that we do not have gas. We are an EVM chain right now. We want to be VM agnostic, started off as EVM chain. So EVM necessarily has a technical requirement of gas, but what we've done is we have completely hidden that away. So we have a concept of recycled gas tokens. This is something that is unique to us, and it's only possible, once again, because we are the layer one to launch layer ones. In addition to that, you can have very interesting token designs because of that gasless experience and because you are looking at an infinitely scalable system. So let's keep going. Thank you. It means that TPS is a very difficult question to answer on here, but difficult for a good reason. So if it is a monolithic layer one, you more or less know that when you stress test it, you have your TPS number. These are the numbers that all the major chains try to put out there in order to prove their performance limitations. So for us, there aren't any. What we did earlier with mainnet is we stood up 500 chains. Just stood them up, 500 chains. When you have 500 chains, what that leads to on Saga is 1.1 million TPS. Now that is assuming you have 500 chains, but you can see that TPS is a function of how many chains that you have. So once again, hitting home the point that performance on Saga is actually about standing up additional layer ones. And it takes you, again, a couple minutes to stand one of these up. If you are a human developer, we are starting to get into the AI space where AI agents are the ones who are standing these chains up for AI agent-only environments. But I mean, that's another talk. But in terms of TPS, this is how we think about it, which is why for us, it's a very difficult question to answer when people ask, what is the performance of your system? It really depends on how many chains there are, and you can have as many chains as you want. So let's keep going. All right, which brings me to our liquidity integration layer. Next slide, please. All right, so solving liquidity fragmentation. I'm sure for those of you who are technical or if you've been in the space for a very long time, you recognize the problem immediately, is when you start to scale across multiple different block spaces, the system fragments. So you have liquidity that is trapped in each individual chain, and unless you have a fully interoperable system, that liquidity is going to remain trapped in that chain. That ecosystem is going to be much poorer as a result. So we really needed to solve liquidity fragmentation. So what we have done with liquidity integration layer is all assets can freely transfer between the different chains within Saga. That's table stakes. But it is also the case that all chains on Saga can have their tokens transfer freely in and out of the Saga ecosystem, period. And you can also transfer in tokens from outside of Saga to any one of these chains. So even though it is a natively multi-chain environment, once again, it's a layer one to launch layer ones, even so, you have the same experience as if you were building on a monolithic layer one. Okay, so everything is automatically composable. The message passing that happens in the background is fully standard according to the Saga OS. And this is a way in which you can achieve a fully integrated liquidity environment despite the fact that everything on here is on its own chain. All right, next. We talked a little bit about removing gas from tokenomics. So let's dive a little deeper into what that actually means. Okay, so recycled gas tokens, once again, we are first and foremost EVM. That means that there is the technical requirement of gas. So when you instantiate a chain, you do have to specify a token denom and a token supply. You can use that as your gas token if you wanted to. You can use a gas token as a fee token. That is built into EVM. However, what most of our applications prefer to do is actually remove the gas experience for the end user entirely and monetize another way. So what they would rather do is to actually open up a faucet that just recycles the gas token. So it's kind of like if you were to go to an arcade, for instance, and you get a bag of tokens to play the games with. So as you're playing the games, you're just slotting in those tokens, and then the tokens just get recycled back into that arcade system. All of this happens on the back end. The user never sees it. The developer is the one who is programming this recycled gas faucet in order to provide for a truly gasless experience for their end users. I will say that the first time that we talk about this concept with any developer that is building on Saga, it takes them a little bit to understand, wait a second, what is happening here? Because no one else is doing this. But once they do understand it, every single person turns on this feature. It is just so much better for the end user experience, and they do see the difference in terms of adoption. All right, next one, please. So next generation DeFi on Saga. We talked about infinite scalability. We have talked about the gasless experience. We have talked about liquidity integration. So what does that mean? So DeFi 2.0, how we think about it is for people in the audience, we're all DeFi people. And so we understand that a lot of the limitations that have been placed on DeFi applications so far are artificial. We have put throttling in place primarily through gas because if you have too many transactions come through, then you're going to kill the chain. So what happens if the chain can't die? Because, again, infinitely scalable. Well, then we can really institute the most beneficial flywheel possible for DeFi. So this is the feedback loop that you ideally want for DeFi on any layer one. So you want to increase transaction volume as much as possible. That leads to more fees generated. That leads to attracting more liquidity, obviously. And it is ultimately cheaper for end users. This is the flywheel that you want to create. It all starts off with that scalability, though. And now that everything is integrated with our liquidity layer, this is something that we can actually implement. What does that look like? Right, so please. So let's get this slide because I just talked about this piece. All right, so we can supercharge DeFi scalability. First of all, launch a chainlet in 2 minutes as opposed to a year from now. And then you can automatically access liquidity as soon as you have that chain up on Saga. Next slide, please. Okay. The first instance in which we are going to find out how this actually impacts the costs for end users as well as the health of the liquidity ecosystem here is Uniswap. So back in, I want to say December 2024, that is when we announced that Uniswap V3 is going to be our canonical DEX. And Uniswap V3 has been deployed across many different chains. This is their first app chain instance, though, their very first app chain. And what we have already started to work on with them is as soon as this chain gets pounded, we want to be able to shard liquidity across as many layer ones as they need in order to support the traffic. Okay, so we are sharding liquidity for Uniswap across multiple chains. Never been done before. We're super excited. We have deliberately set fees on all of our pools really, really low to ensure that the traffic and the volume does reach those limits such that we can start to shard that liquidity immediately. All right, let's keep going. That is the end of it. I did promise you guys some alpha. So what I was talking about there was DeFi 2.0. That is sharding Uniswap liquidity across multiple chainlets. And you're like, okay, that sounds amazing. When is it going to happen? So for all of you in the room, thank you so much for being here. You get the alpha that our DEX opens tomorrow morning. So at noon, at noon Eastern and 9 a.m. Pacific, so 10 Mountain Time, our DEX is going to open, which means our liquidity integration layer will have gone live. Every builder that builds on Saga will have access to immediate liquidity from their own layer one. The DEX is going to go live, so Uniswap will go live on Saga, and I look forward to all of you pounding the shit out of that chain so that we can start to shard liquidity onto other layer ones immediately. But there's not enough time now to talk about the technical achievement that this took, but the Ethereum roadmap for 2025 was all about solving this problem. How do we get rid of liquidity fragmentation? How do we make ourselves a richer ecosystem and work together to accomplish that? And we have done that at Saga. So can't wait to welcome you guys tomorrow. If you want to have any other information about liquidity integration layer, I'm around today. The team is around today. You can find lots of information across our socials. We've been very forthcoming about it. But we can't wait to share this with all of you. Thanks so much.